In this video, we're going to talk about two more area and volume questions. So let's dive straight into the question. For this one, CJC 2011, diagram below shows the curve with equation y equals x squared minus 1, and then you have a tangent line 2x minus 2 at this point, 1, 0. Write down the coordinates of the point where the tangent meets the line. Tangent meets the line. Very easy. Sub in x equals to 3 into this equation. You will get y equals to 6 minus 2, 4. So the answer here is 3, 4. 1 mark. Easiest 1 mark here we'll get. Region R shaded in the diagram is bounded by the curve, the tangent, and the straight vertical line. Find the area of R. You have the first real question here, finding area. So finding area, you either use integrate y dx or you integrate x dy. Depending on which axis you want to use, this one you can do it two ways. Alright, let's start off with the more difficult one, which is integrate x dy. When you integrate the graph from this point to this point, what you're actually finding is this shaded white color space here. So yes, it is not too difficult. You can find the entire rectangle here, minus away the purple shaded area, minus away this triangle to get the remaining, which is shaded region R. So three things you gotta find. You can also do this. You can also break it up into, draw a line here. This is 4. And then we break it up into the purple area. So the top part of R is this rectangle minus away this purple area. Then you have this red color area here, which is integrating with respect to y, 0 to 4. Then you take this rectangle, minus off this red color area, and you minus off this triangle. Why you want to split here? We'll keep that in mind. We will take a deeper look into this in part 3 later when we are finding the volume. So for now, just recognize that yes, you can straight away find this purple part, rectangle minus purple part minus triangle, get R. This is if you choose to integrate with respect to y. Alternatively, you can also integrate with respect to x. In fact, that is the better choice of these two. What you do is you are integrating with respect to x, so you're using the x-axis and the curve. When you integrate the curve using the x-axis from 1 to 3, what you're finding is you're finding this entire area. After that, subtract away the triangle, and then you'll get region R. Simple enough. So let's just do this question using this one, because I am lazy to make x a subject here, because here I can straight away dump in this y function, throw it inside. I don't have to make x a subject. See, if you make x a subject, later you still have to square root this and you have to choose the right curve because it gives you the positive and negative. So let's use this and not use this for now. Integrate y dx from 1 to 3 equals to integrate x squared minus 1 dx from 1 to 3. This will give me x cubed over 3 minus x evaluated between 1 to 3, which will give us 27 over 3, 9 minus 3, 6. 1/3 minus 1. Minus away, minus 1. This will give us 6. Minus away, negative 2/3, which is actually 6 plus 2/3, 20 over 3. Then subtract away the triangle. Half times base times height, 2. This is 4. So triangle is just half times 2 times 4, which is 4. R is equals to 20 over 3 minus 4 equals to 8 over 3. We're done with part 2, 2 marks. Part 3, the exact volume of the solid of revolution obtained when R is rotated 2 pi radians. That means 1 whole round about the y-axis. So this time they chose this as the axis of rotation. We have 2 integrate pi x squared dy or integrate pi y squared dx. The choice has been chosen for us. There is no need to use this one here because this is using x as the axis of rotation, meaning you spin it this way. We're never ever gonna get the answer if you use this, so we do not use this one and we use this one instead. Then now you have to think about what kind of volume we're gonna get if we spin this shape here. Now you can try doing it the same way you found the area using rectangle minus this shape here, minus this pink color shape here, and then minus away the triangle. You can do that. However, when you spin this triangular part, it's pretty hard to find the volume because it is not touching the y-axis. So what I suggest you do, instead of finding cylinder minus this shape, minus triangle, I suggest, like we did above, we make an incision here, right here, breaking R into two parts. The top part, which is this red colored bit, we're gonna get by spinning this vertical line around, which will actually give us a cylinder. Then we will subtract away this bit here to give us the remaining volume, the top half of R. Then we will add spinning around this tangent line to get this shape, a trapezium bowl. Then we subtract away this red color part here, which will give us this red color part. So let's go ahead and find the boundaries. Here we already know from previous part that this is 4. What about here? This is where the vertical line meets the curve. Vertical line 3, x equals to 3, 3 squared, 9, 9 minus 1, 8. Set up the integration, integrate x squared dy from 4 to 8. I'm finding the red color cylinder, right? Minus away, integrate from 4 to 8, x squared dy. Now choose the correct formula. Choose the correct expression to put inside here. This one is this vertical line. So it's simply x equals to 3. So you can either put 3 inside, or you can do away with this integration altogether and just calculate the cylinder using pi r square h. And then we will subtract away this curve, which is y equals to x squared minus 1. Here I will make x squared the subject as simply y plus 1. We're done with the first top half of volume R. We will add the bottom half of volume R, which is integrate from 0 to 4, x squared dy minus integrate from 0 to 4, x squared dy. Choose the correct function to put inside this x. Here we will use peach color. Peach color is actually this one, y equals to 2x minus 2. Make x the subject, y plus 2 over 2, then we square it. Y plus 2 over 2 squared. This one, once again, we will use the curve, this red color part. X squared minus 1, so x squared is y plus 1. Doing this is not too difficult. First of all, find the cylinder. The cylinder is pi r square h. R is 3. R is 3. The height is 4. So pi 3 square times 4 will give me 36. So 36 pi minus away. This one I will get y squared over 2 plus y with the pi on the outside evaluated from 4 to 8 plus, now integrating this, before that let me pull out the 1/4. Y plus 2 square dy minus, this is just pi y squared over 2 plus y evaluated from 0 to 4. Simplifying this, sum in 8, 64 over 2, 32 plus 8, 40. Sub in 4, 16 over 2, 8, 8 plus 4, 12, so minus 12. Plus pi over 4, integrate this will give us y plus 2 cubed over 3. This would be 16 over 2, 8, 8 plus 4, 12, minus 0, so simply this. So 36 pi minus 28 pi minus 12 pi plus, this would give me 52 over 3 pi, and after doing some calculation, this will give us 40 pi over 3. That's the answer for this question. Last question in this topic, we will be doing a parametric equation curve. So you have this, write down the Cartesian equation of C. C is made up of these two curves. We are supposed to make t the subject and try to form an equation in only x and y. But it will create some issue because if you were to make t the subject, this will be tangent inverse y over 3. We can't possibly squeeze this into here and call it a day, can we? We can't say that, oh, this is 2 secant tangent inverse y over 3. That's not a very nice equation. So what we do is we have to make use of our knowledge and link up secant and tangent. So if you brainstorm a bit, you will realize that this is the way to link up tangent and secant. Secant square is equal to tangent square t plus 1. So make secant square t the subject, you will give me x over 2 square. And then here I will have y over 3 square equals to tangent square t, this thing plus 1 give you this. So this thing plus 1 gives me this. Simplifying it further would give me x over 2 whole thing square, which is x square over 4 minus y square over 9 equals to 1. This, from the topic of conics, would give you a hyperbola. So let me delete all this and sketch the curve C, stating the equation of the asymptote and the coordinates of the point where C crosses the x-axis, if any. So you don't even have to whip out your GC, but it's still good because you don't know how much of the graph you want to draw based on these boundaries. So plot it on a GC. You should get something like this. Now don't be worried about all these blue diagonal lines you see. What happens is the GC, they are going to plot points. What they do in parametric mode is they connect the dots. So they connect. And once they are here, if the next point is here, what they do is they literally connect it. So this is why you see this. This actually does not belong to graph. As we know that hyperbolas are just like that. These are actually the asymptotes. So under parametric mode, the calculator actually accidentally draws out the asymptotes for you. They do not belong on the graph. This is not supposed to be a solid line. So take note. So how much of it do they want you to draw? You have to change the window from negative pi to pi. Here should be negative pi to pi. You'll end up with the same amount of stuff to draw. So the graph is actually just a hyperbola, a full hyperbola. What is the x-intercept? Just equate y to 0. You will get 2 or negative 2. So this is 2, this is negative 2. What are the asymptotes? To do that, revisit the chapter of graphs. You just need to equate this to this. Square root both sides. Attach the plus minus on the x side. Make y the subject. You'll get 3 over 2 x plus minus. So this graph is positive 3 over 2x. This graph is negative 3 over 2x. The two asymptotes are done. And this will be graph C. Next part, the line y equals to root 3x plus k is tangent to C. Show that k is negative 3. You don't know where the tangent is, but we do know that the gradient of the tangent is root 3. So to find the gradient, we have to go back to our dy dx. Here we can find dx dt is 2 secant t tangent t. Your dy dt is equals to 3 secant square t. Your dy dx would be this divided by this, which will give us 3 over 2 secant cotangent t. Simplifying cotangent t, secant t. Secant is 1 over cos t. Cotangent t is cos t over sin t. You just give us this, 3 over 2 sin t. Equate this to root 3. We will get 3 over 2 root 3 equals to sin t. Now you can go and actually find the value of t, but it wouldn't be a nice number. What you do is Because after all, your job is just to find out what is the x and y coordinates. Where is this tangent at, right? We need to find the x and the y coordinates of this particular point of tangent. Your job is not to find t, but you're supposed to find 2 secant t and 3 tangent t. What do? We draw the triangle. If this is t, sine is opposite over hypotenuse, 2 root 3, 3. Doing Pythagoras theorem, this should give you root 3 here. Then x would be 2 secant t. Secant t would be hypotenuse over adjacent. 2 root 3 over root 3, and then you times 2. That would give you 4. What about the y value? 3 tangent t. 3 tangent t, you will get 9 over root 3. Rationalizing this would give us 3 root 3. So we now have the point where this tangent is occurring at. So 3 root 3 is equals to root 3x, which is 4, plus k. K would therefore be negative root 3, shown. 3 marks. Finally, the region bounded by the tangent, where this is 4 and 3 root 3, right? So if 2 is here, 4 is probably here. We're not going to use the point at the bottom because this is a positive value. So the tangent is actually here. Bounded by this blue color tangent, the curve C, x-axis. So we're talking about this shaded region. This shaded region is being spun around the x-axis. Setting up the integration will just be integrate y square dx, because we're using x as the axis of rotation. This part will be the cone generated minus away this gray color volume that is generated. So cone is just 1/3 pi r square h. 1/3 pi r square h minus away this gray color volume. This gray color volume, this is 2, this is 4, so we're going to go from 2 to 4 of y square. So remember, this graph is actually x squared over 4 minus y squared over 9 equals to 1. So making y squared the subject would just be x squared over 4 minus 1 whole thing times 9. So I'm going to squeeze this into here. So 1/3 pi r squared h minus pi 2 to 4. Put the 9 outside, x squared over 4 minus 1 dx. So now let's calculate the volume of the cone. We need to fill up radius and the height. So go back to this, the cone. This is the cone. This will be the radius. This will be the height. The radius is just this length here, which is the y coordinates 3 root 3. I'm going to fill this in. Radius 3 root 3. What about the height? The height is where this tangent line cuts the x-axis. So when y is 0, x would just be 1. So the height is 3 units. Now after you're done with this is just a matter of solving the integration and subbing in the values. In fact, the question says calculate the volume obtained. They never say exact volume obtained. You can go ahead and use the GC and solve for the answer. Just mash this entire thing in and then give your answer in 3SF. Alternatively, you can just do it by hand. It's not too difficult. Cancel. This will give you 27 pi minus 9 pi. Here you will get x cubed over 12 minus x evaluated from 2 to 4, which will give you 27 pi minus 9 pi times, subbing in 4 will give you 4/3, subbing in 2 will give you negative 4/3 as well, so this minus negative 4/3, 27 pi minus, here you get 8/3, cancel, 3 times 8, 24, final answer, 3 pi. That's it for this question. If they want you to leave it in exact form, it will be 3 pi. Otherwise, you can just use GC and key in this step and let the calculator do all the hard work for you. That's it. Thanks for tuning in.